भुवनेश्वर जो उसमें पहला इवेंट जो है वही।
हाँ मैं ट्विटर पे देख लेती हूँ।
भुवनेश्वर जो उसमें पहला इवेंट जो है वही।
हाँ मैं ट्विटर पे देख लेती हूँ।
भुवनेश्वर जो उसमें पहला इवेंट जो है वही।
हाँ मैं ट्विटर पे देख लेती हूँ।
Hey, hi. Good afternoon, everyone. Thanks for tuning in. I'm not sure whether this is live or not. So let me just check.
It's live minutes.
Okay, thank you. Okay, thank you everyone for tuning in on a Saturday afternoon to Pyladies Bhubaneswar. So we had our last meetup on 25th July 2019. So this is a pleasure. We've been planning for this for so long, but finally it's happening. But in such a time that we are not able to meet face to face, but technology has us all covered, and we are right here. So. Cool. Let's get started. So before I start, I'd like to give a huge shout out to Nancy Chauhan right here. You can see her. She is a software engineer at Grofers Gurgaon, and she's helping us with the live stream because I have bad internet connection and I really can't help it. So thank you, Nancy, for your valuable time. So yeah, one more thing is I'd like to share the link to the event. So, while if you have questions, you can just put it on the live chat. Otherwise, I'm trying to share my screen, but I'm not able to. So, let me just have a look. Okay. So if you have any questions, you can just either just go to this slido.com and just click on this code right here. Otherwise, you can just scan the QR code and get started. So you needn't wait for the talk to end to shoot your questions. You can just shoot it right away whenever you find it. So, getting started with the first talk, we have Amitosh Swai Mahapatra. Amitosh is a software engineer from Bangalore, India, and he works at Gojek, maintaining a transaction pipeline for millions of users in Southeast Asia. He's a speaker and a passionate open source contributor with contributions in Fedora, Elastic, Fossey Foundation, etc. He also maintains several open source projects in Python and Node.js. He loves doing digital art, sketching, cooking. You want to add anything, Amitosh? Okay, anyways, he's going to speak on static typed Python using MyPy, and he's going to talk about how we can improve our code by using static typing incrementally and throw light upon advanced techniques for improving performance using statically typed code. So I'd like to hand over the control to Amitosh. Over to you, Amitosh.
Yeah. Hello everybody, and thank you, Manashwini. So, like it's a difficult time for all. Like we all are locked inside our houses, and it's great that we are doing this over digitally. Like it's a great thing that we can do it over digitally without gathering at a place. Still have the comfort as well as maintaining the safety of our own. So I wish everyone is safe and sound. And with this, I'd like to start with my presentation of the static typing in Python with MyPy. So just yeah. So if you are this is about static typing with Python using MyPy, and a little bit about myself. I work at Gojek. Like Manashwini has already given a great introduction of me, so I just add a few more. Like I contribute to open source here and there. Like sometimes I draw, sometimes I color, and you can find me at GitHub, find me at Twitter, and I'm currently in Bangalore. I'm originally from Qatar, and I have been working in Bangalore since last 1 year at Gojek. And so this is all about me. Now let's get started with our content. Yeah. So this is today's agenda. Like we are going to talk about what is static typing, what are the features of that Python provides for static typing our code, and like what is duck typing and how can you mix it with static typing, like where to use what, and finally how like you read about this concept, then how do you want to actually implement it in your project. Now this is about it. Now let's start with the question about what is static typing. Now you all might be familiar with C++ and Java. So the typing that they use is essentially checked by the compiler, like hey, it's a string type variable, you can't put an integer here. That is the summary, the TLDR of static typing. Like you know what parameters we are going to pass and what is being returned by a method. Like what kind of object does a variable hold, like what methods and what properties does a given object is have, and all this information is available before running per application, that is during compile time. Let's take a simple example. Like you have this len function that can take as an accept a list, a tuple as an input, and always returns an integer. So a list and tuple is in our static typing module that I'm going to introduce is defined as a union type called sequence. So here I mentioned the type sequence, which is just a look at, it's a peek ahead of what's going to come. So and about the history of static typing in Python. Python was originally dynamic typed, so like everyone was proud about how Python is dynamically typed, and I mean a lot of awesome things are possible by the fact that Python itself is duck typed. Now you can pass anything anywhere. You can change objects in the runtime. You can monkey patch. You can you can add decorators that are like that can entirely change how Python code is working. Now you can do all this, and this is all due to duck typing. But there was a cost of duck typing. In duck typing, you need to remember what you are going to pass into a function, what a function is going to return, what methods or variables or a class is going to have. Now, once they started writing a lot of Python code, programmers felt a need to specify a set of expectations of what a method will return or what a method will accept. Now, out of all this, PEP, that is Python Enhancement Proposal 484 was born. Like it hinged upon the annotation syntax for Python that I will also describe in the coming slides, and added type hints to it. Now, this type hints enabled a set of tools to, like in a standardized way, to actually parse your code and see that your code is corresponding to a particular set of expectations that you are defining. Now, if you want to return a string, you should always return a string. You are nowhere returning something like an integer or a string. Like, I mean, if you have such kind of code, that means you are going to have problems in runtime. Now, another thing that needs to be like told about Python static typing is it's a strictly runtime static typing. It's a strictly a compile time static typing, and there is no runtime checking ever. Now Python still remains the weakly typed duck type in its core, but something like Java, which can throw something like class not defined or a class cast exception in runtime, you don't have those things in Python. I mean, the static typing is supposed to be implemented as something like pylint linter, or it's just like a linter that you can implement when you are running your Python code. Now, before going deep into static typing, let's start with the starting with the basic current model of Python which is duck typing, like how duck typing is implemented. So here's the philosophy of duck typing. If it walks like a duck and it quacks like a duck, it's a duck. I mean, you judge just by some particular set of properties that an object satisfies, not by its signature or not by its identity. So if you have two objects that has a method called dance, and you are passing it into another method called dance that requires that the object that passes have a method called dance, you just need that. You don't need anything else. Now this allows for a lot of runtime and modification of code and lot of dynamic patterns of code. Like you can also generate code during the runtime. You can add variables, remove variables, add methods, remove variables. These all things are possible because your code is defined by your behavior, not by identity of a particular element. While this sounds good, but it has some pitfalls. Now, take this example. Now, on the left side, I have a duck. It's a buffalo duck. It quacks. It has webbed feet. It walks like a duck. Hence, it's a duck. And here I have a mallard, which is strictly not a duck, but it's kind of a duck. So it quacks, it has webbed feet, and we treat it as a duck. So this is the entire phenomena of duck typing, where it's like the quacking and walking is defined by this. So now from the duck, let's come with a like example, a hilarious example that I wrote. Like this is the story of the duck simulator. So you and several teams are building a multi-billion-dollar duck simulator to predict how ducks are going to change the world. Now we are going to run various types of scenarios on how ducks are going to change the world. Like ducks will find solution of, like, let's say, global warming or something like that. You have got so much money and you are writing, and we all love Python, so we are writing our simulation code in Python. Now you started to like increase your broadening the scope of your project, and you started adding several duck-like bats like mallards and several other species of ducks. You started adding them, so that, let's say, if our domestic duck is not able to be a very efficient global warming cleanser, maybe a mallard could be a cleanser. So we all started doing this. Now we are not one, we are like having 1,000 people. They are divided into multiple teams. Now you are the team, like you are part of the team which is responsible for building the simulation, and all others are busy defining the various attributes of the duck, and they are defining it as accurately as possible. Now you have a team that is like modeling our buffalo duck, and you have a team that is modeling our mallard. And ducks and mallard are quite similar, and many of you, if you think of a duck, actually think of a colorful female mallard that I just shown. So, but to be honest, they are quite different. Now, but for our purposes, they are quite similar, and our simulator is like a bit simple. It just treats everything as a duck, and it works. I mean, at least it works for now. Let's see what happens. Now teams are all busy building different ducks, and one day you said that okay, ducks can fly. Ducks actually can fly at a very high speed, and they migrate from like thousands of kilometers. So you decided to see how flying can make ducks a bit more adaptive to global warming, and they help us learn how to tackle global warming. So you decided to implement fly in your simulator. Now you made the spec change to every team. Every team implemented the change, except there's a team that was mocking a duck called as a Fuegian steamer. Now these ducks are a variety of ducks that they don't fly. So they did not implement the fly change. And they saw your specification, but they were not really sure whether fly is a required attribute or not required attribute. So they were dumb, or for some reason they did not implement fly. And they wrote their test. They followed all the testing patterns, like they tested with mocks and all. And they also tested with integration tests, but integration tests really don't cover much of all the things. So testing pyramid is a different topic, and we're not getting into that today. But somewhere they wrote their test. The test passed, and you all integrated together, and you started to run your simulation. Now your simulation started to fly on all the varieties, and it ran fine for everything except when it encountered a Fuegian steamer. It crashed, everything broke loose, your simulation failed, your budget went down. So you really don't want to have this kind of behavior happening in a production code. And by my experience, even after writing so much tests, sometimes somewhere a little bit of dynamically written code goes in, and things happen, things break. I mean, we have monitoring in place, but why to break in the first place? So with codes like having tens and thousands of lines, mistakes like this happen. You cannot remember what exactly a particular class is having and what exactly it is holding. So your brain can only process a finite amount of information, so let's not overload it. So let's outsource this task into a tool that does this guarantees checking for us. So this is how the static typing PEP 484 came into picture. Like prior to that, we had type comments and all, but they were basically IDE features that are happening. Now with MyPy, it's a reference implementation of the PEP 484, and it's a gold standard for Python static typing. It runs part of your lint process and has absolutely zero runtime overhead. So if you are deciding and you are worried that whether adding a new check is going to slow down my application, then it's not the case. You can go ahead, you can straightforward implement MyPy and everything will run as you wish. Now, here's an example of a code that uses static typing. Now here I have imported this type called sequence, which basically is a union of list and tuples. And what it does, it is when I've defined a function that does some magic and returns me the answer to all the questions, that is 42. So it takes in sequence, and sequence is it's a type that implements iteration and it returns an integer. This is a very simple example of how to write types. You just write colon, you specify what is the type, and you write integer. Now there's some more example. Now this is a class, and class we have properties, and similarly you can annotate each property with strings like with unit price, this class inventory item has this name which is a string, unit price which is a float, quantity on hand which is integer again, and this total cost function that returns a float. Now you can also define individual variables which are part of your code, like part of a function, but this is generally unnecessary because MyPy is smart enough to infer what this particular type is going to be. So that really is unnecessary unless you want to force some typing which is similar to typecasting, but we want that this kind of behavior would actually might lead to crashes in future. So when I don't want you to do like annotate variables unnecessarily. So there are just some examples. Now there's some details about how the Python type system works. Now we have classes. Now you can use any class as a type qualifier. Like you can use int and string that we saw. You can use classes from system libraries like path, logger, or you can define your own class or own data class and see. And you can also annotate a method argument or a method return type with that. So you can also use this types everywhere, like in your constructors because they're methods, and also results of expressions, also in lambdas expressions and all. Also, Python has supports for generics. Like if you want to define a generic class, or you want to use something like let's say I want a function that only accepts a list of strings, you can use this. Now typings has some of the predefined classes of Python like dictionaries, tuple, string, name tuple, etc. They are in typing, in which you have a generified version of it, so that you don't have to re-implement your own. Because the original classes like list, original built-ins, they did not have generic support. So typing improves on this and adds its own generic. So it's nothing different. It's just that your type annotation would be from typings, but the actual code will be still running from the standard library. So with 544 PEP, you have things like protocols, where it uses a thing called structural static typing. Let's say if you are familiar with Java, you have this interface called closable. That's mean that all the streams and all the resources they handle, they implement closable, and they explicitly implement closable. Now protocols are a bit advancement over this syntax, over the interface syntax. Like they say, hey, like any class that defines this particular set of like particular set of fields and a particular set of methods, they are compatible with me. You don't have to do something like an abstract class or use something like ABC or ZOP interface or something. Just directly define the protocol, and any class that satisfies this will be automatically accepted there. So it's a deviation from, and it's quite. If you have used Golang, it's quite similar to the interface in Golang. The protocols in Python work in the same way. Now, one other thing that I'll stress on is Python type system is only compile time, means only check before running your application. And while running, you have no type checking anywhere, you have nothing available, but you can still get the type hints, like what are the type that this particular function or this particular class method accepts. You have that information, but the check is not done. And type system is fully fully compliant with inheritance and other sorts of like object orientedness that you want, or you have Liskov substitution principle, which is basically says that if something is accepting a if something accepts a superclass, then hey, can you hear me?
Yes.
Yeah. So I just got a ping from Manaswini that she lost me. I guess she's off.
Yeah, might be.
Okay. Okay. So with Liskov substitution principle, if something is accepting a superclass, then you should technically accept all its subclasses. Now I say here, it's mostly preserved, as in the type system will accept any subclass, but it's up to you to actually preserve the LSP, because in Python we don't have signature based type inheritance or type method overriding. It's like if two methods are same, you can override it. So if you deliberately write something that violates LSP and it accepts a different set of arguments, then Python is not going to be of much help out there. So it's up to you. But this is all about now how to use types. Now you need at least Python 3.6 or MyPy. And if you want to use protocols, then you need Python 3.8. And Python is not a all or nothing feature. You can start with a single file or a single module and add typings as you play around with the code. And even if you don't want to use additional end step like MyPy, type hints will improve your IDE's code completion. Like if you are using something like PyCharm or Visual Studio Code or even Vim with Coq, then those tools are really integrated with the Python type system, and they will greatly improve your development experience. Like they will give you accurate suggestions. So like I personally prefer it for this reason. Like my IDEs will be much smarter with type annotations. Now type annotated code will be accepted by Python or PyPy without any modifications. Like you don't have to strip out type annotations. It's all valid Python code. So you don't need to fear about adding an additional preprocessor step in your build step as well. Yeah. So you want to run MyPy, then if you want to take some example, then take a file, add some type codes and install MyPy, and then just MyPy and module name, and it will do all its type checking, and it will print out errors if any, and if there are no errors, then it will just happily exit without any output. And if you want to, I would recommend you to include MyPy as a part of your build step in your CI. Like if you are using a CI, if you are not, then you should write some make file that calls MyPy and then a sort of tests after MyPy. So now MyPy, unlike TypeScript, doesn't require any pre-processing. I earlier told you that everything that you write is all valid code, and if you want to play around with the type information in the runtime, you have this function called get type hints that will say, okay, this particular variable is annotated with this particular type. So you have all that information available, and some tools in the Python ecosystems actually make use of this information. Now, let's say you actually want to build something like a runtime check type system, then you have this function as your building block and you can start doing it. And if you read the PEP, then they actually mention the uses of one usage of community uses that they say is like building a runtime type checker, but I don't know whether you actually want to do it or not. So that's it. And here is something what the Python type system is not. Now it has no runtime checking, as I earlier said. There's no impact of performance. It doesn't need any extra compilation step. It is not a new language. It's all valid Python, and it doesn't force you to use types everywhere. Now, if you want to leverage types of improving performance, there are other tools that I'll be discussing. But type system itself is not going to give you any speed up or something. It's just going to make your development a bit more error free and bit more accurate. So that's all about it. That's all the type system is. Now there's some interesting usage of Python types. Now there's this library called Pydantic. It's a validator that is fully described by Python types. Like you define a class, you define what types of values this class is going to read, and you want to instantiate the class with the particular values and add some decorators in the class about let's say value should be greater than 10 or something. Then it is going to validate for you without writing a full validator in something like JSON spec or something. Just write it and it works. And Fast API is a new framework. It's like Flask, but it's much faster. And it describes its input parameters. Like for API, the bodies that you are going to send, you can describe it using Python types. Now internally, it is based on Pydantic, so they work the same way. Now there's another tool called MyPy. It compiles any type annotated Python code you throw at it to a Python based extension. So Python code are precompiled to your architecture, they are optimized, so they are pretty fast. So you are using libraries like pandas or NumPy, they are usually backed by Python based code.
Amitosh, you can continue.
Yeah. But I got a ping that my video is having some issues.
Yeah, it's lagging a bit, I guess, but it's fine.
Okay.
We can live with that.
Okay, that's fine. Okay. So this was about types, and this is like going beyond types. So there is a Python feature called slots that help you to enforce some static typeness in runtime. I mean, slots are basically a feature that says, okay, my Python object of this class is going to have this many functions and this many number of attributes. Nothing can be dynamically injected into it. So this also gets a bit of safety in your code, that if you are having some code that is something that is affected by someone, writing something by mistake, then slots will help you catch it. So slots are totally tangential to types. So there are some libraries like auto slot and auto type that help you to add it, and they're again based on static typing. Now retype is a tool for converting a large Python code base and adding type annotations where required. And if you actually start using types, then you can slowly think of writing some parts in Python which are compiled, so they are particularly very, very fast. So you have some part of code which is very latency sensitive or very speed sensitive, you can use Python there. Then this is it about typings. So if you have any questions, I'll be taking questions right now. So write it in the Slido or write it in the the YouTube chat, and I'll be answering them. Yeah. So let's start the Q&A.
Thank you so much, Amitosh. I'll just share the Slido screen. I lost connection in between, so sorry for that. Yeah, feel free to share your questions. You can just go to slido.com/ just go there and just write this code. Otherwise, just scan this QR code and get your questions there. Otherwise, you can put it in live chat as well. I'll be moderating that. Okay, no questions till now. Okay, no problem. We can move ahead with the next talk. And we'll be sharing the slides and the contact details of Amitosh so that you can contact him in case you have any questions.
Yeah, thank you, Manaswini, for this opportunity, and thank you all for attending my talk. So, okay, let's move forward.
Thank you, Amitosh. So next up we have Mahima Gupta. Mahima is presently working as an associate data scientist at Tally Solutions. She has interned with Red Hat prior to that. She is a postgraduate from IIIT Gwalior, a batch of 2020. She is a free-spirited dancer, loves hosting events and playing badminton in her free time. So she is going to introduce Ada Boost and XG Boost for all the aspiring data scientists right here, how they work and how they are different from each other, bias and variance in them as compared to decision trees. Over to you, Mahima. Mahima, are you there? No, Mahima, you're not audible. Mahima, can you hear us? Okay. I guess there is some issue with the mic. Yeah, sure, Mahima. So we have got some free time, so we can, so all of you can just post your questions right away. So even if it's related to Amitosh talk, it can be, it will be there. So just feel free to post your questions in the meanwhile. Yeah, Mahima, you're audible now.
Great. Audible? Done?
Yeah, you are.
Okay. Yeah. So, hello everyone. So today, I will be discussing boosting technique for classification. So, as I'm not much aware with till what level you have been through data science and all these algorithms and all. So I will first try to give you a short introduction so that we can build up on in AdaBoost. And for that, I would like to present my screen first. Manaswi, can you stop sharing the screen? I think it's not showing me the option. Yeah. Yeah. Can you see it?
Yes.
Okay. Okay. So, so first of all, I would like to take an idea on the YouTube chat. Maybe how many of you are aware about like decision trees and classification algorithms? Just a quick like a yes or no, so that I can accordingly go into that much of depth. Because today I will be taking up this AdaBoost algorithm, and I will explain it to you with the help of an example, so that it will be very easy for you to understand how it actually works. So if all those who have joined and who are listening to this could just quickly reply. All right. Okay. No worries. I'll start.
We got no response in the live chat, so I guess
Yeah.
there is something lagging. So no problem. We'll be moderating on the go. Please continue.
Yeah. Sure. So, all right. So, the first example that I'll be taking is like this. So, basically, in machine learning, we have various kinds of problems. So, in this today's talk, I'll be dealing with classification problem. So, I've just taken a small data set here, which is a really sample of all the kinds of data set present in the industry. So this is a small data set which shows there are features which are chest pain, blood circulation, blocked arteries, weight, and all these features. The values to these features tell me if the patient has a heart disease or not. So this is just a sample of the data set that I'll be dealing with today, and with this, with the help of this example, I'll explain you how the algorithm actually works. So there are already many classifiers that are available with us, like logistic regression, decision trees, naive Bayes, SVM, even neural networks. So AdaBoost actually works on the principle, not on the principles, but it is like a taken forward algorithm from random forest, but with certain changes. So random forest, you must be aware, it is a collection of decision trees. So there is a main difference between the two, between random forest and AdaBoost, is that one is a bagging algorithm and the other one is a boosting algorithm. So first, I'll give you a brief idea of how the two differ from each other. So what happens in bagging is we make various trees. In the random forest, we make various trees. Okay, so anybody wants to say something? Okay. Yeah. So we make various decision trees to form a random forest. And for that random forest to work, all those trees are independent of each other. That is, we take random samples from our complete data set, and then we form various decision trees which are independent. But in AdaBoost or in boosting, you can say all these trees that we make are not independent of each other. The second tree that we make is always dependent on the first tree. How is it dependent? Is that whatever mistakes my first tree makes, I take all those into account and try to make the second tree to cover up those mistakes. So this is the basic difference between bagging and boosting. Now the other difference that comes here is, so I'll give you an example from real life. Like suppose in UN, there is a voting happening, and all the countries are giving votes. So now, suppose there is something that if we have to boycott China or something like that, suppose. So some countries say yes, we want to boycott, and some says no, this is not correct, we should not do it. So if we give all of them equal weightage, all the countries equal weightage in their voting, that procedure will be bagging, because we are giving them all equal weightage. But there is a thing called what is that, veto power in UN. So some 5 countries have a special power, so they are giving more weightage in their voting. So even if one says no, then it's a complete no. So that is the basic difference between bagging and boosting. So you can say it's equal voting and weighted voting. So this is how I will explain to you how boosting differs from bagging. So AdaBoost lies in boosting algorithm and random forest lies in bagging algorithm. Now I show you how random forest looks like. So this is how random forest looks like. So suppose these are basically decision trees. There are many decision trees, and all of the decision trees have given their respective predictions. So the first one predicts 1, the second one predicts 0, the third one predicts 1, and so on. So now we see the 6 of them have predicted the answer to be 1, and just 3 of them have predicted it to be 0. So the final answer that we get is that the prediction must be 1. So this is how random forest works. Now, alright, so there is one more thing that I'll tell you later on when I explain you how AdaBoost actually works. So now here what happens is, there is no special, suppose there is one tree which actually got the features rightly placed and it gave a better prediction as compared to the other tree, but there is no special weightage given to this tree. To overcome this problem, or not problem, to basically give it a better solution to it comes AdaBoost. So all the boosting algorithm, as I told you. So the pictorial representation, you must have seen this diagram in many blogs and in many places where they explain boosting in this way. So I'll quickly explain this, how it actually is working. So you see there is a box 1, there's a box 2, and there's a box 3. Consider them as some trees. There's tree 1, tree 2, and tree 3. So now tree 1 has separated all these plus and minus. So these are 2 classes, plus in one class and minus is the other class. So they have all divided them into blue section and green section. Now in the second tree, as you must see, the 3 plus are increased in their weight, because in the first tree, if you see, there were only 3 plus that were not included in the blue section. That is, it thought that these are wrongly classified and I should pay more attention to these 3 plus now. So it increased its weight. As now you see, when it increased the weight, the classifier shifted the boundary to the more plus side, and now all the 5 plus are in this boundary, in the blue boundary, saying that all of them belong to 1 plus. But now you must be seeing that the 3 minus came into the blue section. So in the third tree, the blue minus, the minus signs have a greater size. They are given more weightage. And combining all these 3 trees, you can see in the tree 4, I have got a perfect classification where all the plus and minus are in a different section.
Sorry, Mahima, sorry to interrupt. Can you please present your screen? I mean, the whole content is not visible to the audience. Thank you.
Oh, okay. It is showing me that my screen is being shared.
I think it's visible.
It's visible, but I mean, just present. Just click on the present button.
Oh, okay. In the full. Okay.
Okay. Thank you so much.
Yeah, sure. Yeah. So I think this. So this is like a pictorial representation. I'll actually now tell you how this weightage is actually given. How this plus sign gets bigger and how the minus sign gets smaller according to the mistakes that the previous tree has made. So that we'll do with the help of the example that I had taken in the first slide. Alright. So this is just to give you a start for the random for the adder boost. So here you see in random forest, each time we make a tree, we make a full size tree. Like whatever features are there, all the features are included in all the decision trees. It is not like we'll take some of the features in one tree and some other features in the other tree. No, all the features are taken in all the decision trees, and there is no depth defined for the tree that we'll make the tree up to 6 nodes or we'll make the tree up to 7 nodes. It is just that all the features will come in the tree, and now according to whatever decision is being made, the size of the tree will be defined. As you can see here, it is skewed. The above tree is skewed. The lower one is like a balanced tree. But what happens is in AdaBoost, all of my decision trees are just one feature tree. So all the trees that I make have a single feature, and such a kind of a tree which just has a single feature is called a stump. So I think you got the first basic difference between the two. There are complete trees, and here there are small trees of just one feature with 2 leaves, one node and 2 leaves. So, as I already told, had it been a random forest, this would have been the tree that would have been made for such a data set. So, there is chest pain, there is blood circulation, there is weight, there is blocked. All of them are the features, and according to them, it has been decided if the patient has a heart disease or not. Unlike this, in AdaBoost, what I'll do is, now you see. Okay, there's one more concept that I would like to introduce here. Just tell me if there is any term that you're not aware of, or if I'm not able to explain it well. So, okay, so I'll not go into much of depth of what is bias and what is variance. Just for an introduction, bias is basically whenever I train my model. So bias is the capacity of my model to completely understand the data on which I have trained it. So bias is basically an error. So if I am not able to understand it, I have high bias. So basically my target is to have a low bias and a low variance model. So if my model is not able, all right, yeah. So so bias is the capacity of the model to completely understand completely fit on the data that I am having the model on. While variance is the capability of the model to generalize. Now suppose there's a small kid. I'm explaining the kid how a dog looks like. Okay, so I have shown him a couple of examples: a German Shepherd, a Pomeranian, a pug, and so many examples. And now now if I say that the kid has low bias, that means all that trained data on which I have trained this kid that this is a pug, this is a German Shepherd, if he is able to tell them all correctly, then the kid is in low bias because he is able to understand his data properly. But now suppose I bring a new dog to him and he is not able to recognize that this is a dog, depending on what I had taught him that okay, dogs have furs, dogs are brown, or sometimes they are white or whatever. But he is not able to understand that this outside dog that this woman has got to me is a dog, then he is having a high variance because this kid is not having the ability to generalize his information. So I think this is a broad perspective to what bias and variance is. So I hope you won't forget it ever in this context. So why I told this is because weak learners have high bias and low variance. So weak learners, these stumps are called weak learners. Why are they called weak learners? Because they are just taking one feature into account while they are making a classification. All right. So okay. So this I have already told that in random forest all the trees have equal mode, but in AdaBoost this is not the case. In AdaBoost, whichever tree will make a better classification will have more say in the final prediction. And then this one is okay. As I told, in random forest, all the trees were independent, but in AdaBoost, it is a sequential formation of tree. Second tree is dependent on the mistakes that the first tree made. Now this I already told. Yeah. So now, how am I going to further create this AdaBoost stumps? So this is the data set that I am having, which says that these features lead to a heart disease. These features don't lead to a heart disease. Now what I have done is I'll give all of these data set points. These are called data points. So there are 1, 2, 3, 4, 5, 6, 8 data points. So first thing that I'll do is I'll mark all of the data points having equal weight. I'll say that all of this information is equally important to me because this is the first stump that I will be making. I don't know what mistake this stump will make or whatever. So in the first place, I'll give all of them the same weight. So here you can see, because they were 8, I gave all of them an equal weight of 1/8. Right? Now, when we make the first stump, after we are done with the first stump, it has made some mistakes or whatever, then we'll have those sample weights changed. Now you can create an analogy with what I told you in the initial slide when that plus sign was increasing its size. That will come into picture in the after this first stump has been made, and these sample weights will change according to the mistakes that this stump makes. Now, all right. Okay. So because I already told you that the stump just takes one feature at a time, so I'll check with chest pain. So this is a simple decision, as you must have been doing in all your classes and everything. So I've taken chest pain and I say the left arrow indicates yes and the right arrow indicates no. If there is a chest pain, yes, heart disease. And this is no heart disease. So this is basically I am classifying the data set as you can see in the first data point it says there is a chest pain and there is a heart disease. So this is yes. So this goes into the correct classification point. In this manner I have divided them into that. Okay, there are 3 correct data points that I have, 2 incorrect data points I have in case of when there is a chest pain. So I think you are getting this point that all this correct and incorrect is on the basis of the feature chest pain. Similarly, I'll do for the next feature, which is blocked arteries, and I'll see okay when I take this feature into account, how many correct and how many incorrect data points I get. Similarly, I will do for weight. Now this is the thing that I won't get into this particular session, that why I took this 176 and all. This is a simple technique that goes into account when we study decision trees and random forest. So these 3 ways I have got that. Okay, these are the 3. All these 3 features give me this much of correct and incorrect data points. Now there is one thing called Gini index. Now I'll again shortly explain this to you. Gini index basically is telling me which feature to split on, which stump should I first select? Should it be chest pain? Should it be blocked arteries? Should it be weight? And how does it tell? It tells it by suppose I take a feature. Suppose if the case is if the patient has chest pain, if the patient has a heart attack. So this is a win-win situation. I don't have to do anything. This is the best feature in hand. I just split on chest pain because I know if the patient has chest pain, he will have a heart attack. So this thing Gini index indicates. So I'll select the minimum Gini index. You can go and study more about it so that you can have a better idea. I won't go into much detail of this particular thing, but all in all, I have told that how Gini index works. It basically tells you what is the best feature to split on, the minimum value we take. So we have taken this weight stump as our best feature to split on. So now you see, I have selected this stump, and now I know, okay, just a second, let me hide this. Yeah. So now you can see the number of correct and incorrect classifications. Now, as I had told you, that the classification that a stump makes decides its final say in the last prediction. If you remember, I had told you in the beginning. So when you come, so this is the calculation of Gini index, which we'll skip for now because otherwise we'll confuse you to the next level. Yeah. So you see, in this stump, what is the total error that this stump made? Now you come to this thing, that this stump that is there, these green boxes. So there is just one incorrect case that you can see. So there is 3041. So 3 correct, 0 incorrect in the left side, 4 correct and 1 incorrect. So there is all in all 1 incorrect data point. So the total error that this stump has made is 1 by 8. Alright. So now going back to that pictorial thing that we had started with, this particular that is red highlighted in this slide, this particular data point has been wrongly identified by this stump. So now I need to give this particular data point more weight so that my next stumps keep into mind that I have to keep this data point correct as well. Alright. You can ask me questions in between also if there is any confusion, so that it does not linger on to the last.
So there is a lag of 5 to 10 minutes. So I guess questions will be pouring in as soon as they get it.
Oh, alright.
Yeah, okay. Please continue.
So yeah, so where was that? Okay, so I have highlighted this data point that this is 1 by 8 error that this stump has made, and now my next stump should keep in mind that I don't have to repeat the same mistake. Now you see. Okay. So here, okay, a little insight that suppose all of them, suppose this was correct was 0, incorrect was 3, here correct was 0 and incorrect was 5. So all of them would have been incorrectly classified by the stump, right? In that case, the total error would have summed up to 1, because 1 by 8 plus 1 by 8 plus 1 by 8 times, the total error would have been 1. So the best case scenario, error equal to 0. Worst case scenario, error equal to 1. In this case, we have error equal to 1 by 8. Okay. Now we decide based on the error made by the stump, we decide the amount of say that the stump will have in the final output. How do we define the amount of say? This is the formula for the amount of say, which is half log 1 minus total error divided by total error. So don't bother with the formula. I'll show you a graph. So this is the graph. So as you can see, as the error increases, so on the x-axis we have total error, and on the y-axis we have the amount of say. As the error increases, the amount of say decreases, as you can see. And you can also see when the error total error is 0.5, the amount of say is 0. You can just see and draw the line and see that at error 0.5, the amount of say is 0. Alright, why is it so? Because if the total error is 0.5, what does this indicate? This indicates that this stump is of no use. It is equivalent to flipping a coin. Because error 0.5 means sometimes the patient will have a heart disease in case the weight is greater than 176, and 50% of the time will not have a heart disease. So it has made 50% of the error. So in the final say, this stump will be null and void. There will be no amount of say for this stump because it has given me an error of 0.5. Now the next you come, okay, this slide I already explained you. Okay. Yeah, and as you also see, as the total error goes to 1, the amount of say gets negative. That means if the stump if this stump says that the patient will have a heart disease. So because this stump is having an amount of say which is negative, its final say would be considered as that the patient will have the opposite of what it decided. So as you can see, how do we define the amount of say? The formula was already there. With this formula, we get 0.97. So why do we get 0.97? Because the error was 1 by 8 in this case. So in the graph also you can say that when the amount of say was, the total error was 1 by 8, which is 0.125 I guess, the amount of say comes up to be 0.97. That means this stump is doing a pretty well job. So it will have an equivalent amount of say as what it says. Now, similarly, we will have to do for the next feature. The first feature we already identified, which is weight, which we identified using the Gini index. Now the second feature we take as chest pain. When we divide by chest pain, you can see in this blue-green figure that there are 3 incorrect data points that chest pain has given. So the total error comes out to be 3 by 8. And when the total error comes out to be 3 by 8, the amount of phase lies somewhere between 0 and 0.5, which is I've not written a value here. Okay, but this amount of save will come in between 0 and 0.5, as you can see here. Unlike the previous one where the amount of save was 0.98. Why so? Because there the error that the stump had made was just 1 by 8, unlike in this case where the stump has made a greater error, which is 3 by 8. So now we have to see how do we modify this weight for the incorrectly classified data point. So how do we do that? Abhi tak we have made the stump, the first stump. We have identified the incorrect sample, the data point, and we know that now we need to give this a proper weight so that my next stump knows what to do. All right. So how will we do that? So this is now a next formula which says new sample weight is equals to sample weight, which is the present sample weight, which is 1 by 8 for the incorrectly classified one, into e to the power amount of say. I'll again show you a graph. Alright. So putting the values here, alright, leave aside the values for once. This is the amount of say on the x-axis and sample weight is on the y-axis, new sample weight. So more the amount of say, more is the value for e to the power amount of say, that is, more is the value for new sample weight. Because you see, if there is a really good stump, okay, and that stump is making really good predictions for all of the data points except one. So definitely I have to give that particular incorrect data point much larger weightage than all the other data points, because this system has already best classified all the other data points. So greater the amount of say of the stump, greater is the new sample weight for the incorrectly classified sample. And lesser the amount of say, lesser is the new sample weight. Now you see here the new sample weight come out to be 0.33 with all.
I don't think so, but it's not available, and I'm not getting to see the data. It's showing me live data. I mean, sorry. Okay, no data. Okay, I think it's back right now.
It's back, right?
Okay, yeah, it's back.
Okay.
Thank you so much.
Sorry for the inconvenience. There was net issue. Yeah. Sorry.
Okay.
Everyone.
Okay. I understand. Thank you.
Yeah, that's okay.
Yeah, Mahima, please continue.
Okay, so I was here. So basically, I was telling that that now I have repeated that same sample 4 times into my new data set, which is basically equivalent to giving it more weight because the first one could not classify it perfectly. So yeah. So so now again we'll make we'll do the same thing. Now we'll again give them the same sample weight 1 by 8, 1 by 8, 1 by 8, because now our data set has changed. Not like really changed, but the data points, the occurrence of data points has changed. Now the same procedure will be done all over again to make the second stump. Now, now finally all the stumps have been made with the same procedure. Now suppose these 4 stumps I get which say that the patient has a heart disease. I think you get this, that now we'll get more data from outside, some features, and we'll have to predict if he has a heart disease or not. So these stumps say, these 4 stumps with this particular amount of say 0.9732 and so on, say that yes, the patient has a heart disease. So we add up this amount of say, and which comes out to be 2.7. So there's a 2.7 what I should say weightage to the fact that the patient has a heart disease. Now suppose there are these stumps which say that the patient does not have a heart disease, and the amount of say for these stumps are 0.41 and 0.82. So the total comes out to be 1.23. So 2.7 weight says that he has a heart disease, and 1.23 says he does not have a heart disease. So we go with the fact that the patient has a heart disease. So as you can now again see the difference between how AdaBoost and Random Forest works. In random forest, we would not have taken this amount of say into consideration. We would have just counted the number of trees. That okay, here 4 trees say that he has a heart disease, and here only 2 trees says. So we would have said that okay, he has a heart disease. No, in Adamos we took amount of say. Kiss tree may, like which tree is more correct. That should be given a more say in the answer. So this I already told. So we finally decided with okay, the patient has heart disease. So okay, so why add a boost? Okay, so this is a final thing that for today. So why add a boost is it is simply these are different algorithms. Okay, classification algorithms that we have. It is just that as I already told that add a boost has something extra as compared to random forest because it is working with the random forest trying to reduce the variance because in decision trees there is a problem with the variance, but if you do random forest you work on variance because you are now able to better generalize. What Adaboost works as in bias, it tries to reduce the bias. How? Because it was because every next tree was made keeping in mind the mistakes of the first tree, so it tried that it is able to best model the data that it has been. Generally performs better than random forest. So in machine learning, it is not necessary that you have to apply a neural network or you have to apply an Adaboost over random forest to get a better answer. It is just that what algorithm suits which data the most. You can just run a linear regression or a logistic regression and get better results and save your time from running a whole lot of neural network and stuff. So yeah, so that was pretty much about it. I won't go with XGBoost today. Sorry, a little change in plans because Adaboost I try to explain in depth. So I thought of not including XGBoost as the time was not that much with us. So yeah, this was all about Adaboost.
Thank you so much, Mahima, for your time. So yeah, let me just
Should I
share
stop
the
sharing?
yeah. Thank you.
Okay.
I'll just share the screen of Slido. Okay, you can see the questions, right? Mahima, are you able to see the questions?
Yeah, I can see the questions.
So what kind of data Adaboost is more suitable than random forest?
All right. So as I already told, okay. So let me think of some good example for you. Okay. So suppose, all right. So suppose you have a data set where you have applied random forest. Okay. Now this random forest has been is able to generalize well with the outside data, but you find that there are outliers in my data that this random forest is not able to capture. So generally, whenever I have such kind of data which has outliers present in it, okay, outliers. If you're all aware of a data point which is not very similar to the other kind of data points. So Adaboost helps me with that because I already told that Adaboost tries to reduce the bias in the data set in the model. So, and what is bias? It is the ability of it to fit into the data set that I am modeling it on. So, whenever I have a data set which has more sort of outliers, then I would prefer to go with Adaboost rather than random forest. I hope I cleared it. If there's something else.
Thank you so much, Mahima. I guess that answered the question, but I'll be having a look at the live stream as well.
Sure.
So in case there are any outstanding questions, I'll just post that in the live stream and you can just answer it there.
Yeah. Okay.
Okay, guys, feel free to shoot your questions, even if she's going off mic right now, but still she'll be there available in the live stream chat. So you can shoot your questions to her and she'll be able to answer it. Thank you so much, Mahima, for your time.
Yeah. Welcome.
Okay, next up we have Lucky. So Lucky Suman is working as a data scientist at Zoomcar. He has worked as a data scientist at Red Hat prior to that. He has had experience working in domains of machine learning like natural language processing, recommender systems, CV, and optimization algorithms. He likes spending his spare time singing, gardening, dancing, cooking, playing badminton, and chess. So he's going to conduct a hands-on session on various pre-processing techniques and methods for various NLP use cases, their difference along with their applications. I'll be handing over the control to Lucky. Over to you, Lucky.
Yeah, hi Manaswini. Thanks a lot for introducing me. So, should I share my screen?
Yeah, please go ahead.
Okay, just a second. Are you sure?
Lucky, are you able to share your screen?
Yeah, is it visible now?
Yeah, it is. Thank you.
Okay. Okay. So yeah, hello guys. So as Manaswini mentioned that I will be introducing the pre-processing techniques, various pre-processing techniques in NLP. NLP represents natural language processing over here. So I want to know that how many of you people know about NLP before, like at which level do you know about the NLP and this pre-processing techniques and this use cases. So please let us know on the YouTube live chat. So meanwhile, I will start with my hands-on presentation of in Jupyter Notebook. So I think it is visible, right? Okay. Yeah.
Yeah, it is.
Okay, thanks Manaswini. So I will start with the introduction of NLP and like where it is used and what is this basically and why do we need to do pre-processing over here. So as I told that NLP represents natural language processing. So according to our industry, like whatever like in the world of machine learning, in the world of data science, only 21% data is out there which is structured, which is in structured format. Apart from that, everything is in unstructured format. So among those unstructured format data, text data or textual data is some kind of data that it is very full with noise and very unstructured kind of. So today I will explain that how to remove those noise, how to make the text more visible or more insightful, so that our model, our machine can understand it better. So like you use chatbots, you use WhatsApp, you use any mail and all. So all kind of data, like mostly data around us, it's in text format. So obviously NLP is very key thing for us to learn in machine learning in data science domain. So as I written here that NLP is a branch of the data science that consists of systematic process of analyzing, understanding and deriving information. So obviously it's very readable form. It's very in readable format that we use NLP because of we want to analyze the text. We want to take the insights from the text that written text is positive or negative about us, because our human head also need to learn that what is the like what does the text say basically. So it is like it gives us some sentiment kind of thing, the emotion behind the text, like it is the positive, it is the negative, or it is the hateful, it is the grateful kind of. So there are lots of use cases out there in NLP. So now I will start with the text pre-processing. So as I told that a text is the most unstructured format of the available data. So there are various types of noise are also present, which are present in the data, some such as the stop words. So it's like at the rate, hash, and anything like exclamation mark, question mark are useful for us to understand a text, but not useful for understanding the machine. So obviously we need to remove those. And why do we do text preprocessing first? Because everything in the machine, everything for the machine, everything for the computer is a vector. So the my document, whatever I'm presenting, whatever I'm writing, whatever I'm seeing, so it represents as a vector. So let's think about that. Ki, okay, if my document is there, so let's say ki, my name is Lucky Suman and I'm presenting in Pyladies Bhubaneswar. So here every word will represent a vector, and my whole sentence will make a line or will make any curvature in that vector. So let's say if my sentence consists of 5 words, then obviously I have the 5 dimensions, and my particular sentence made of the 5 words are it is a 5 dimensional vector. So for reducing the dimension, for reducing the dimensionality, we need to do pre-processing. So you can take anything as an input. So whether you can take the image, whether you take the recommendation data, whether you take the speech data, whether you take a text data, you need to reduce the dimension, because it is a more like it's like the more dimension, more computation for the computer. So obviously we want to reduce the dimension, we want to reduce the computation. So that's why the pre-processing helps us a lot. So there are various techniques in text pre-processing, but currently today I will present a very basic or very important, very essential pre-processing which you need to do. So there are various Python modules as well out there for performing pre-processing, such as the NLTK, Spacey. There is text blob as well. So there are lots of, but NLTK is the kind of state-of-the-art module for the text processing for Python. So today I will be starting with that. So NumPy and pandas are essential if you want to import the data frame and all. And obviously NLTK is useful, so you need to import NLTK. So for downloading NLTK, you just write pip3 install NLTK. Then it will download the NLTK for you. But then you need to download the NLTK.download, because it has a lots of code for lots of packages out there. So you need to download those. So you can just select. Basically, it will open a UI for you. You can select the packages whichever you need, and then you can download it. So after that, you will be you will be going with the use of NLTK. So first thing I wanted to explain, which is the tokenization. So what's the tokenization meaning? So it's like if you have a document, if you have a story, if you whatever you have. So let's say ki, you have some text, you have some research paper, and there are lots of sentences. Okay. So how does a human mind read a text or read a newspaper, read a research paper? So basically, it breaks the particular paper, particular thing into a sentence. Then it breaks the sentence into words. So again, tokenization performs the same thing. So it's a process for breaking document into sentences, and again those sentences into words. So here each word or each sentence. So basically, and the broke component, the component which came out after the breaking the sentence or breaking the document is known as a token. So if I am breaking my document into sentences, then each sentence will represent a token for me. And if I am breaking my sentence into words, then obviously each word will represent as a token for me. So NLTK gives us the two methods over here. So you need to just import the NLTK tokenize, and you need to import the send tokenize or word tokenize from the NLTK.tokenize class. So if you want to break a document, so if you want to create a sentence tokenizer, then here is the function for that. So this function will take the input document as a input, and then it will use a send tokenize function or method from the NLTK, and then it will break that particular document into sentences. So basically, this will work as the sentence tokenizer, and the same thing will follow in the word tokenize as well. So here you have the tokenized sentence, and each sentence will work as an input for this function, and then you need to use the word tokenize function from the NLTK, and it will break the particular sentence into words. So here you can see that I created a one dummy document, which is over here. So my document says that machine learning is awesome, NLP is the most interesting domain of ML. So obviously, how will you read, or how will someone read this particular sentence? So first he will read this machine learning is awesome. Then there is a stop word for me. There is a there is a stopper for me. Then I will stop over here. Then I will just pre-process it. Okay, what does it say? Then I will read the second data, which is the NLP is the most interesting domain of ML. Again, the full stop is over here. So same thing. So my tokenizer should behave like this. Okay, it should give me the list of two sentences, which is the machine learning is awesome and NLP is the most interesting domain of ML. So I run this. So you can see that if I run this, I can get that machine learning is awesome is the one sentence and NLP is the most interesting domain of ML is the another sentence. So that's how our document is basically is divided into two sentences, and it will give me the list. So that's how you can tokenize a particular document into sentences. Now we will move forward with the words. So obviously again, so machine learning is awesome or NLP is the most interesting domain of ML. So how will you read it? So first you will read the NLP, then is, then the, then most, and then so on. So again, you need to break this particular sentence into words so that my computer can understand it better. So I will perform the word tokenization over here. So if I use the tokenized sentence, which is the word tokenizer, so it will take a sentence. So my text is over here is NLP is the most interesting domain of ML. Then it takes as an input and it will give me the list of words which are from the sentence. So here you can see that NLP is coming as a one word, then is, then the most, and so on. So that's how you tokenize the particular document or particular word, particular document, particular sentence in NLP. So for if you are using NLTK, then it's very easy. So but if you are using some other modules such as Spassy and text block, then mostly they do on their own. They don't need to they don't want to ask you that, do you want to tokenize it or not. They just tokenize it and then they just perform the pre-processing over here. But NLTK gives you the basically hands-on experience over there. Ki, okay, I'm giving this method as well. So just if you want to use it, then please go ahead. So again, the same thing is over here. Now we will move forward with the noise removal. So obviously tokenizer is the best thing, not the best thing, but it is an essential thing for us. So because you need to perform the tokenization before any pre-processing you want to go ahead. So what are the noise which presents in my text or in my piece of text? So basically whatever the information which is not relevant for me. So again, it's a domain specific. So let's say for let's say for a medical domain or for a banking domain. So it's like some text is in my banking domain. Then obviously they will not be interested in the knowing of the any pharmaceutical information over there, unless until if they are holding a pharmaceutical company, bank and account. So basically financial domain will not need any information about any tablet or any information about any person kind of. So again, so it's a very domain specific. So whatever the text or whatever information which is not relevant to your use case, which is not relevant to your particular text information, then those piece of information considered as a noise. So for me, so it's like generally, like it is very generally. So commonly used words or commonly noise are in the language, which is so basically those are the determiners and helping verbs and all. So is and the, of, in, prepositions and all. So those are not those will not give me any information while I'm doing the while I'm performing the my use case. So if I want to train a classifier, text classifier, and so I will not be using of this is and the, because these words or these things are useful for the human mind, but not for the machine, because machine only understands the numbers. So in this hands-on session, I will explain that how to convert the text into numbers. But before, let's remove those stop words. So the noise which is coming on that piece of information which is not relevant for us are also known as a stop words. So generally, when you take the Twitter data, so in Twitter data you can see that lots of hashtags are used over there, lots of user mentions which is used by the at the rate and all. So lots of are there. So you need to remove those. So how can you make a go on function kind of this? So here, so let's say ki, for me, for my particular information is a and this, and some dot is not relevant information for me. So I made a list over here, so it will work as a vocabulary for me. Then I wrote a function of remove noise from the input text. So obviously the input will come over here. Then I need to split it. So it will by default the split function splits the text on the space. So basically this particular space it will split on over here. And then I will noise free words. So basically I will remove those words, or I will pick those words which are not in my noise list. So this basically this list composition will work like this. So if you will see, so I can print also. So here you can see that my input was that this is a sample text. So here you can see that in my noise list is and this are the irrelevant information for me. So it picks only the sample and text, because it didn't pick any word from the noise list, and it gave me the sample text, and I just joined it and made a sentence. So that's how the noise removal works. That's how the stop word removal works. So I know it's very pretty easy. But yeah, that's the essential step for the NLP pre-processing. But obviously, if you will make the vocabulary or the list again and again, so it's a very tedious task for to do. So NLTK corpus will gives us a stop words vocabulary. So it contains lots of stop words in different languages, which are generally or which are majorly used as a stop word in the text. So I just use the same function over here. Here I just instead of split I use a word tokenize, because again my input text will come, and then word tokenize will split this particular sentence into words, and then this list comprehension will pick those words which are not in the stop words vocabulary. So here you can see that my text is Ram likes to play chess, but he is too fond of board games as well. So here you can see that if I apply the remove stop words, so it removes the to and is, he, and two, because those are the prepositions or pronouns which is not relevant for me, which are not useful for me. So basically this is a these are these those words which is removed from the text are considered as a majorly stop words. Okay, so here I am giving you the peak of the stop words. So here you can see that this is the corpora for that. So here you can see that there are lots of languages over here. So English is there, German is there, French is there, even Urdu is also there. So there are lots of languages out there. So basically NLTK is an open source library which used to update month by month. So they updates the corpora of the stop words over here. But now you can see that if I will use this text which is which considers at the rate and which uses hash as well, so those are not removed by the stop word. So again you need to make your own function for that. You need to make your function so that they can remove the unwanted letters or unwanted words from there. So I use regex for that, because regex currently it performs fast as far as, but if you will write a long regexes, and again it will very slow. but just for removing of one or two letters, it's very useful. So you need to import the RE, which stands for the regex, and then you need to give the input of the text and the regex pattern which you want to remove. So here you can see that I use the find function, which will find the regex iteratively in the text, and then I use the re.sub, which will substitute that particular pattern to empty string. So here you can see that my regex pattern tells that any at the rate or any hash will come, then space, and if the space is there, and after that any word is come or any letter is coming. So with the infinite iteration, then just please remove it. So here you can see that at the rate flat earth society, I have a joke on earth, but it's too flat. Hashtag I have a joke on. So before removal, so I'm just printing the before removal and after stop word removal and all. So like here I performed remove stop words first. So which is this function which I use over here, remove stop words function, which will remove all the stop words which are defined by the stop word corpora by the NLTK. Then after that I will remove the at that and hash all the irrelevant letters for us. So if you can see that before removal is this is the normal text for me. Then after stop word removal, you can see that it removed have and which is the helping verb and the determiner. Then it also removed it is and all. So it removed those stop words, but it didn't remove at the rate and the hash. So if you can see that my regex button also follows like this. So if at the rate is coming, then at the rate is over here. Then if space is coming, again space is over here, and then the word is coming. So it's like the this word particular this word. So if it is coming, so obviously this is the at the rate, this is the space, and the word is coming. So obviously it will remove this, and the same pattern will follow over here. So after final removal, which is the after removal the regex pattern as well. So you can get I joke earth and flat. I know this might not look like very intuitive, very informative for you, but trust me, basically these words, the joke and earth and the flat, these are the words only which is insightful for me if you are working on a long data sets, long corpora. Currently, I am using only one sentence. That's why it will not make any sense to you. But it's a very essential technique to remove any unwanted patterns or unwanted words from the text. Now, so basically these are the normal Python functions which I use. But now let's go to the NLP algorithms. That how does the NLP performs, and how can we use the grammatical information of the words. So basically I will just explain over here. So it's a POS tagging now. So POS tagging stands for the part of speech tagging of the sentence of the text. So what does it do? So it's like okay, so let's say Lucky Suman is playing badminton. So here you can see that like it's the very primary school English. So Lucky Suman is playing badminton. So again, Lucky Suman is a noun, is a helping verb, and playing is a verb, and then badminton is again a noun. So the same thing. So did you see that I just tagged a particular sentence or a particular word to the I just tagged a particular word like it that this word is a noun, this word is a verb, this word is a pronoun kind of thing. So POS tagging does the same thing. So here you can say that every word in a sentence is also associated with the part of speech tags. So basically the noun, verb, adjective and adverbs are known as the part of speech tag. So if you are tagging a particular sentence to these, so means you are doing the POS tagging. So it's as simple as that. So the POS tags defines the users and function of a word in the sentence, because these POS tags or these grammar means a lot to me, and it will give me the lots of information about the how does a sentence made, or how did my sentence will give me the emotion kind of thing, or give me the sentiment of that particular sentence. So currently NLTK uses the perceptron tagger by default. So basically it's an algorithm which is the average perceptron training algorithm, which use the tagged data of the all the big corpora, and then perceptron model trains on it, and it gives us the output, tags as the sentence for us. So here you can see that you need to import the POS tag from the NLTK. So from NLTK import POS tag. Just a second. So now you need to write a one function which is the apply POS tagging. So it will take text as an input. Then again tokenization comes in. So you need to tokenize the input sentence into words, and then you need to tag into POS, which is the part of speech. So here you can see the POS tag tokens, which is the equals to POS tag word token. So this particular function will tag all the words. It will do the POS tagging of all the words for the input text. So here you can see that Nick goes to market, but he went there yesterday also. So this is my text, and if I perform the POS tagging, so here you can see that Nick is a noun, goes is a verb, to is to, because basically it's a preposition, but POS tagging does not consider preposition because it considers as a stop word. Because if you will perform a stop word removal on this, so it will remove to from the text, and then again he as a pronoun, then went again verb. So here you can see that that's how a POS tagging works. So it gives me the information that what is the noun, what is the verb, and all. So the same thing happens also in the dependency parsers. If you have ever heard of the dependency parsing, so this is the same thing that my Nick is depending on the goes because it's a verb. Then again this verb is dependent on the market. So that's how a dependency tree forms. But I will not explain to the dependency tree because it contains a lot of information apart from this. So it will take another 30 minutes for me. So today I am not explaining that. So just POS tagging is over here. So if you want to extract the name from the, okay, so what is the use case of the POS tagging over here? So if you want to extract the noun phrases from the big text, so obviously noun phrases will contain the noun and the verb from the text. So you just need to identify the whatever is the noun, whatever is the verb for me, then just join them, and then it will make a phrase, and then just you need to extract out that particular phrase, and that will work as a noun phrase for you. So that's how it is helpful. So for chatbots is also very helpful. So it's like if you are saying that okay, that particular verb is coming first, then the noun is coming. So obviously it will create a function, and then it will suggest you question mark after that function, after that sentence. So that's how a chatbot works also in that. So POS tagging is a very basic but essential technique for the pre-processing of the text. So now I will move forward with the text normalization, which is the fourth thing over here. So currently we completed the tokenization, then the stop word removal, then the irrelevant letter removal, and then the POS tagging. Now we are going forward with the text normalization. So basically, what does it do? So whatever the data is, whatever the type of data is, whatever it is the image, whatever it is text, whatever whether it's speech, whether it's normal data, you need to normalize it. You need to basically shrink it kind of. So that it remove so that it get rid of some dimensions which are not relevant for me. So in the starting of this session, I told that every text or every sentence works as a vector model. So every word is a dimension and every sentence is a vector for in that particular n word dimension. So you need to remove those dimensions so that your computation will not be too much heavy. So you need to reduce those dimensions. So text normalization helps over here for us. Even the stop word removal is also help over here. But how does the text normalization work? So basically, if you are normalizing a text, then it is known as a text flow normalization. It is also known as the lexicon normalization. So which contains basically majorly contains two parts, which is the one is the estimation and the other one is the lemmatization. So again, it's a very primary English. So estimation, it's a rule-based approach, a rule-based process for removing the suffixes from the words. So so let's say if you will give the word playing, PLAYING, then it will remove ing from that and it will return a play. PLAY. So it will remove those suffixes such as ing, s, es, ly, etc. From the word. So here I also gave an example. So it will return you go if you will give goes. So it will remove es from this particular word, and go will be returned. But if you will give so you can take the insight from here that it is giving you the first form of every verb or every word. So it's like if I give played, PLAYED, then it will remove the ed from that and it will give me play. If I will write goes, then it will remove the es as a suffix and it will give me go. So you can deduct that basically it is giving me the first word, but it is not like that. So that's where lemmatization comes. So lemmatization is an organized process where it is the morphological analysis for finding out the root form of the word. So what is the morphological analysis? So it's kind of anatomy of a word, that how does a word basically forms. So it's like if I am using a play, then how my second form will also work, how my third form will also work over here. So basically it's a full end-to-end anatomy of the word. So big deep neural networks are trained on for the lemmatization. So you can make your own stemizer, but it is very tedious, it is very tough to make your own lemmatizer. So again, so we used a pre-trained network from the NLTK for lemmatization. So I will explain that as well. So if you will give vent to stemization, so obviously it will not remove anything, because nothing because there is no any suffix, right? So but if you will give this vent to lemmatization, so it will give you go, which is the first form, which is the lemma of the word. So the first form or the root form of the word is also known as lemma. So that's why this process is known as lemmatization. So now I will explain that this is the stemization for this process. And so NLTK use Porter stemmer. So basically Porter stemmer has a very good rules for the removing the suffixes from the word. So that's why we use Porter stemmer. So it's very old as well. So now there are lots of stemmer in the market, but again Porter stemmer outperforms them, or maybe gives the equal accuracy, or equal basically performs equally. So you need to import the NLTK, then stem, then Porter, and then you need to import the Porter stemmer. And you need to okay, this Vernet basically used in my lemmatization. So yeah, so you need to then initialize the Porter stemmer over here. Then you need to apply stemization. So I made a one function. So it takes an input as a text. It takes text as an input. Then again it will break that text into words, because the word is a so basically it's like a cell. So word plays the same role, word plays the same role as a cell performs for the body. So so for us, the cell is a unit for our body. Again, the word is a unit for our text. So you need to tokenize each sentence of each document into words again and again. So again, I tokenize my sentence into words. Then you need to stem it out. So you can use a stem function for the stemization, and I iterated this particular function to my whole list, and then it gave me the stemized tokens. Okay, so I performed one sentence over here also, but first I will explain the lemmatization, then I can give the example for both. So here you can see the lemmatization. So for this process, we need to tag our sentence. So as I explained that we need to perform the POS tag. We need to perform the POS tagging, or we need to tag POS to the words for performing lemmatization, because it needs that. So basically, it asks for us to us that what. So for which kind of word, like for which kind of POS tag the word you want to find out the lemma. So it is like if you are doing for verb, then obviously it will use that particular verb neurons, and it will give you the verb lemma. And if you are using noun, then it will give you the noun lemma. So you need to give the POS tag to this lemmatizer. So here, so as I told that you need to import WordNet for the lemmatization. So I just replacing over here. So you can see that we use WordNet lemmatizer. There are lots of lemmatizer apart from WordNet, but WordNet is a very vast data set for the training. So that's why a WordNet lemmatizer performs very good. So again, STEM is the same class. Then on in that particular class, WordNet is also. So in from the WordNet, you need to import the WordNet lemmatizer, and you need to import the purpose also, which is the WordNet. So here you can see that I wrote a function for convert NLTK tags to WordNet tag. So as I told that that's how my POS tag looks like: NNP, VBZ, PRP, RB, NN. So basically this NN, this NNP, this NN are nothing but those are the noun. This VBZ, VBD are nothing but those are the verbs. So obviously you need to make a collective representation for those. So that's why I wrote this function. So whatever tag will start with J, then it's an adjective. Whatever tag will start with V, it's an verb. Then so on for noun, and so on for adverb. Okay, and if nothing tags over here, then please return none. So here you can see that for 2 there is no POS tagging because it's an stop word. If you will see, then it's an stop word. So basically it gives me the same thing which is the capital word, but that's why I didn't write. So apart from this JVNR, if anything starts with any letter, then just return none. Okay, so that's how the NLTK tag to WordNet tag works. So now we need to apply the lemmatization. So so basically it will give me one. Okay, so here I applied the POS tagging first. So it will give me the list of the tuples, which is the with the POS tag the words. Then I just use this particular dictionary to make my WordNet tag, which is again a token. So basically, it will return me a tuple of token plus the WordNet tag. So then I just I just make a sentence out of the. I just make a sentence out. Sorry, I will just take a word and then I will append in the lemmatized sentence if my tag is none. Else I will just give that word as an input to lemmatizer, then it will lemmatize for me, and then it will append in the lemmatized sentence. And after that, because I have a list of words of the lemmatized words, then you need to make a lemmatized sentence for, by using those words. So that's why I joined over here. So again, the same text, which is the Nick goes to market, but he went there yesterday also. So here you can see that Nick goes to market is in present tense and this is in the past tense. So here, if you will give if you will give to the stemizer, so after stemization you can see that Nick go to market, but he went there yesterday also. So what does it do? Basically, it removes the s from this, and it can't remove any suffix from the word because there is no suffix for the word. So that's where estimation doesn't perform well. So because it didn't give me the lemma of the word, it just removes the suffixes for me. But but in the lemmatization process, it removes the es from this. So it gave me the root form of the goes, which is go. Then again, it gave me the root form of the went, which is go. Okay, so Nick go to market, but he go there yesterday also, and so that's how the lemmatization estimation works. So till now I just told that how to clean your text, how to remove the stop words, how to create a POS tagging, or how to use those tagged words into the real use case. But I still I didn't tell that how to convert a particular text into numbers so that my computer or my machine can work on that, or can perform the analysis over upon that. So here vectorization comes in the picture. So as I told that computer or machine doesn't understand text or image or speech, whatever you can give, they don't understand. So you need to convert the particular input into the number so that my machine can perform some computation on that, and then it will analyze. So you need to so basically the converting of the text into numbers is known as the vectorization. So if some sentences, so it's kind of a black box. If some sentence you will give, and then some numeric vector will come out. So how does that black box works? Basically, I will explain now. And again, there are lots of processes, but I will explain a very simple process over here, which you can perform or which you can write. So this process is known as a vectorization. So here I explained that there are majorly three types of vectorization. The one is the bag of words, TF-IDF, word-to-vec. So bag of words, I think most of you know or heard about the bag of words, which is I would say it's a mother of the vectorization process in the NLP. Then the TF-IDF, which is a term frequency in the inverse document frequency, and the word-to-vec. So word-to-vec basically it's a deep learning model. So today I'm not explaining the word-to-vec and TF-IDF because it will take another half an hour for me to explain. So I'm just explaining the web of words, which is a very key thing. So yeah. So again, I wrote that today I will present how to present text into vectors with bag of words. So okay. So here, why do we call bag of words as a bag of words? Like why it is not a set of words or words? Why it is bag of words? So if you will, so if you have lots of what should I say? If you have lots of letters in front of you on the table, and someone told you that please collect those letters in a bag, so you will not take care of the number, the ordering of those letters. You will just pick the letter and then you will just drop in the bag. So that's how the bag of words will also perform. It doesn't care the order, the basically it doesn't care the order of the words in a sentence. It just takes the word and just put it in a list and then told you, okay, this is my words, and just perform the computation over there. So that's why it is known as a bag of words. So as I over here keep bag of words, because any order of the words in the document is discarded. It only tells us that a particular word is present or not in the document. So, for example, let's say we have four sentences. The first is this is the first document. This document is the second document, and this is the third one. Is this the first document? So basically, these are the four sentences for me, and these sentences are working as a corpus for me for creating the vector. And my task is to create a vector for each sentence. So how my bag of words or my vectorization will work over here. So here we split or we tokenize each sentence into words, and then we make a list of unique words. So what is the meaning of unique words? So basically, here you can see that this particular this word is coming again and again. It comes in the four sentences. So I will just take one iteration of this, which is this. Then the first document, second and third one. So here you can see that I created a vocabulary, or I would say the unique vocabulary out of these four sentences, and it is giving me it is giving me the length of 9 words as a vocabulary length. Okay, so here you can see that now the question will arise that from the vocabulary, how will you perform or how will you create a vector from it? So so basically what is the basic step over here? You need to count the word. You need to maintain a dictionary, or you need to maintain a count of the particular word which is coming in the sentence. So here you can see that document comes in this particular okay, so basically you need to maintain the frequency of each word which comes in the corpus. So I will explain from the code over here. So again, you need to so there is a count vectorizer which is given by the sklearn library. So you need to import the feature extraction from the sklearn, and then it will give you the count vectorizer. Then I just wrote a function which takes a text corpus, or which takes a list of sentences, and then it initializes the count vectorizer over here. Then it transforms the corpus into that, and if you will convert to array, then it will give you the vector of those sentences, those particular text. So here you can see that my corpus again is the same. This is the first document and all. So okay, here. So after vectorization, unique words from the corpus. So again, I told you it's a 9 word vocabulary, and document first is 1, second, third, and this. So here you can see that my first sentence is that this is the first document. So again, my vector will my vector all my count vectors will be the length of the vocabulary length. So here you can see that in my first document, in my first text, in my first sentence there are 5 words, but my vector is of 9 length. Why? Because my vocabulary length of 9. But now why 9? So here you can see that in my vocabulary end is coming first. But okay, so let me show you this. So here you can see that is this coming over here? No. So okay, so and is coming over coming in the first function? No, because this is the first word of the sentence, so it is 0. Now document is coming. Yeah, document is coming, so that's why it give me the 1. So and so on, it creates the vector for this. Okay, so document is coming, then 1, then is first is coming. Okay, then again 1, then is coming, again 1, then 1 is coming. So here you can see then 1 is not here, then 0, then second is coming, again second is not here, then again 0, the is coming. Yeah, the is coming, so that's why it's 1. Third is coming, again third is not in this not in this text, then again 0. This is coming. Yeah, this coming, that's why 1 is over here. So let's see for the second text or second document. Is and coming? No. So and is not coming in the second document. So that's why 0 is over here. Is document coming? Yeah, document is coming, but it is coming for twice. So that's why 2 is over here. So basically, it gave me the frequency of that particular word in the document as well. Is first is coming? No, first is not in my text. So obviously 0 will come. Then is, then again, so here you can see then third is coming. No, third is not coming, that's why 0 is over here, but third is coming in the third document. So that's why the place of the third there is 1. So that's how. So if you will count the number of ones from a vector, that should be the same length of the text. So here you can see in my first vector, 1 is coming at for first times. So 5 times, so 1, 2, 3, 4, 5, and the length of my first document is also 5 length. So obviously, I'm just taking the attendance kind of thing of the words which are coming in the document. Okay, so now you can use these vectors as for, so basically so here you can see the magic that I just converted the text into vector, which is in a numeric format. So now you can use these vectors. Now computer or machine will understand these vectors, and you can use these vectors for classification, for machine translation, in-ear, chatbot, etc. But this is the very basic thing. And this vectorization technique is also known as the count vectorizer. Why count vectorizer? Because you are taking the frequency of a word also in the particular document. So that's why you are taking a count of that particular word. So therefore it's a count vectorizer. So count vectorization doesn't perform well in the industry because it doesn't take care of the order of the particular word which is coming in the document. But there are lots of techniques such as the TF-ID of Word2Net, which takes care of the order, which takes care of the frequency and all. But if I will explain, then there is a time limitation for me, so I can't explain those over here. But yeah. If you want to know further that what are the other techniques and how to use these vectors into NER, into classification, then please contact me on these, and yeah, you can post on the YouTube live chat and all. So yeah, thank you for this session.
Thank you so much, Lucky. We have a question for you. I'll just share my screen.
Yeah, sure. Should I stop my presentation?
Yeah, sure.
Okay. Okay, how does Zoomka leverage NLP? Okay, so basically there are lots of comments or lots of feedbacks which comes from the Twitter, from the Facebook, from the Instagram, basically from the social media. So you need to basically find out the sentiment behind those. So again, the sentiment thing is a very tough thing for us to do. So it's like some people give the sarcasm as well. So okay, let me give an example over here. So let's say if I take all the negation word, all the negative words as a negative compliment for me. So let's say if someone came, if X person comes and it gives me that, okay, your service was very bad and I'm not happy with it. So obviously this feedback is wrong. This feedback gives me a negative compliment. So I will I will improve my performance over there. But yeah, so this is a negative comment. So it's very straightforward. But if someone comes and give you, thank you Zoomcar for giving me this great trip. I couldn't start my car, or I just enjoyed it a lot. So basically, you can find out that there is a couldn't word, but that couldn't word is not significant enough to tell me or tell my machine that it basically this particular text, this particular feedback is a negative for me. So I will consider as a positive feedback, and I'm like, okay, thanks a lot for the feedback, and we are very happy to serve you. So this will give the wrong impression to the user, to the market. So yeah, that those kind of things we face in the Zoomcar, and there are lots of other NLP use cases are also there, chatbot and all. So yeah, currently we are working on that, but majorly I am focusing on the computer vision part at Zoomcar now. I think this gives the answer.
Yeah, sure, it does. Okay, we are looking for more questions. The live chat doesn't have questions. Even the one in Slido got answered just now.
Yeah.
So I'll just tick it off.
Okay.
Okay.
Thanks, Manaswini. Thanks, people, for joining me and bearing with me.
No problem. We didn't bear with you. We learned a lot.
Okay.
So feel free to send in your questions if you guys are still here. Otherwise, you can just ping them on their social media channels. I'll be sharing that in our social media handles. So cool. Then I'll just stop presenting. Thank you everyone for joining. Thank you Lucky, thank you Mahima. I think even Amitosh has left, so no problem. Thank you so much for your time. Thank you so much for sharing your knowledge. We are elated to have you.
Thank you.
Thanks, Manaswini. Thanks, Nancy.
Yeah. Yeah, huge shout out to Nancy again for setting up the live stream and making sure that it worked seamlessly. So all the other attendees who are there till now, thank you so much for attending the first ever virtual event of Pyladies Bhubaneswar. Nancy, are you speaking?
Yeah, like I'm sorry, I was just saying that no worries. It's I'm really glad to help you, and it was amazing.
Yeah, sure.
Yeah.
Thank you so much, Nancy. So yeah, we'll be sharing the feedback forms real soon. It's there in the description as well, but we'll be sharing it in our social media handles. Feel free to send in your feedback. And yeah, so in this lockdown, just stay safe and be at home and take care. Thank you so much.
Bye.
Okay, bye-bye. Thanks. Thanks a lot.
Nancy, would you mind ending the live stream?
Yeah, I'm just doing it.